seashells, sunflower seeds, pine cone seeds, and some galaxies. What do these have in common? Well, it's a spiral. It is this curved vortex in 2- and 3-dimensional space. And it is common throughout nature. This pattern is ubiquitous in nature. And mathematically, it is represented by the Fibonacci series, which is a sequence that, well, at least according to mathematicians, starts with a 0. So it starts 0, 1, 1, 2, 3, 5, 8, ... And each number is the sum of the two previous numbers. Now I see the 0 as an energetic void, something that happens prior to creation, in the womb, in gestation. And I don't really see it as part of the manifested universe. I see the number 1 as the beginning of the manifested universe, the first number that is birthed. So I like to start the Fibonacci series with a 1. So it goes something like 1, 1, 2, 3, 5, 8, 13, etc., etc. Now, the Fibonacci series has many types of patterns in it, and of course, the most common one is each number being the sum of the two previous numbers. And as you move forward along the this number path, the ratio between two adjacent numbers gravitates towards what they call the Phi ratio, or the golden mean ratio. Now there is another series of numbers known as the Lucas series, and this series begins with a 2. So it follows the same pattern, where each number is the sum of the two previous numbers. So it goes something like 2, 1, 3, 4, etc. And it continues just like the Fibonacci series, where each number is the sum of the two previous numbers. So both of these series represent, or mathematically represent, spirals. So they model spirals from nature. And there are some slight differences in the growth. The Lucas series grows a little bit quicker. But is there more to this? If we look at the Fibonacci series and the Lucas series, we can see that the second number is a 1. In both cases, it's a 1. So Fibonacci, it starts with 1, 1, and Lucas, it starts with 2, 1. So this first number, 1, or the number 1, the first number being born, is this second number. But prior to that is what I call a seed. There is a blueprint that is going to change the structure of this spiral shape over, I guess, over distance, or over time. So we have two seeds. We have the 1 in Fibonacci and the 2 in Lucas. But are there more seeds to this? And there are. There are in fact 9 seeds. So the seeds 3 up until 9 really haven't been explored too much. Of course, mathematicians have mapped that out, and they may not necessarily pay a lot of attention to the first number. But there are in fact only 9 seeds, 9 patterns, 9 archetypal patterns, from the Fibonacci to 1 all the way to 9. And I call this the Phi series. So Fibonacci for me is Phi series 1, and the Lucas series is Phi series 2, and then we go 3 and all the way up until 9. And each of these 9 patterns follow the same structure, where each number is the sum of the two previous numbers, and they all converge on the golden mean ratio at some point along the actual number path. Now each of the spirals that is modeled by these 9 types is a bit different. The Fibonacci spiral is a very tight, so the arms that are extending around a central circle are tighter, and then when you move all the way to the 9th Phi seed, or Phi series, you'll see that it's quite wide, because the numbers go 9, 1, and then 10, and so on. And so the distance between these spiral arms grows quite a bit. So how do we know there aren't more seeds? Of course, we can seed the series with a 10, 11, and 12, and so on. But how do we know that there are only 9? I guess, in some respects, it's our numbering system, our base 9 or base 10 numbering system. but it gets down to what is known as a digital root, so converting a number to a single digit. For example, if we take the number 13, we convert it to a single digit by adding the 1 and the 3 equals a 4. Or we can take a 21, and the 2 and the 1 will reduce to a 3. And when we do this and we compare the various seeds, we find that there are actually only 9 true archetypal patterns. The first seed, or Phi Series 1, is identical to Phi Series 10 in the sense that they both have the same reduced digits. They both go, for example, 1, 1, 2, 3, 5, 8, and then 4, because the value 13 reduces to a 4. And if we look at Phi Series 10, or the 10th seed, it's the same. It goes 10, 1, 11, 12, 23, 35, 58, and so on. And when you reduce this, you get the identical single-digit pattern as Phi Seed 1. So that's really why we have just these 9 archetypal patterns that can describe different spirals in nature. So even though the Fibonacci is let's say a grandparent archetype that describes all spirals, we can categorize things and reduce them a little bit more and be a little more specific about what type of spiral that it is. So spirals that are very tight, tightly constructed circular arms that are weaving around the circle, we can say that's a Fibonacci style pattern, or Phi Series 1. And spirals that are very wide reaching spirals outwards, we can say that's a Phi Series 9 pattern. So each of these 9 seeds or 9 series describe a certain type of form in nature. So I call this basically moving beyond Fibonacci so that we can learn more about the world around us. Now these 9 Phi series I refer to as the Phi series matrix. And this has become, it's actually quite important to understand how these series, or I guess how these reduced set of numbers within these series map to other things in the world around us. The Phi series maps to form. We also have other types of series of numbers, like the solfeggio frequencies, that map to sound. Now, G.W. Hardin created a series of numbers, basically a whole matrix of numbers of 81 3-digit numbers, known as the solfeggio matrix. And in a subsequent video, I will show how this Phi series, which is form, maps perfectly to the solfeggio frequency matrix sounds. So in that series, I'll be able to show that form maps to sound. The Phi series then is a complete set of models that mimic nature, the various spirals in nature. In other videos, I will show more patterns that are hidden beneath these the Phi series, the 9 Phi series, and demonstrate how there are archetypal patterns, there are root patterns and root numbers, and even more interesting equations that we can derive from these 5 series.